So let's just jump right in. I'm going to talk about visual testing. But first, I want to start off with a little game of who done it.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Why, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
But how did you know?
Madam, as any horticulturist will tell you, one does not plant petunias until May is out. Take her away.
That's right, madam.
It's just a matter of observation. The real question is, how observant were you?
Action.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Why, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
So did you happen to see any of the changes? Or maybe the most important one where a dead man got up and walked away? Probably not. And that's because we all suffer from what's called unintentional blindness. And unintentional blindness is where we miss important new things that come into our viewport because we're so focused on the task at hand. And this is especially true when we talk about testing software, right? Because we're so focused on whatever it is that we're testing, we can miss other things that might be going on in the application. So how do we solve for this? Well, typically we'll automate the test, because if we automate the testing, we know that all of the steps, they're going to occur in the same order every time. All of our assertions are going to make sure that we don't miss anything, right? But what if I told you that by automating your tests, you're actually introducing the unintentional blindness and you're scripting it right there in your test? What? Yeah. Because the way that the traditional automation tools work is they interrogate and query the DOM in order to get us the information that we need, right? For example, if I ask, is this text present? Our traditional tools, as great as they aren't looking on the screen, they're looking in the DOM. And they're looking to see if that text is there. And if it is, it's going to tell us, yes, it's there. But what happens if that text is the same color as the background, therefore our users can't see it? What if there's some other elements that's overlapping each other and causing our users not to be able to interact with them? What if we change the viewport size, and in doing so, now some of the key elements are bleeding off the edge of the page? None of this can be caught with our traditional tools. Now, the examples that I gave you, sometimes people say, sounds like some edge cases. Nah, it's not. It happens all the time. When I became knowledgeable about visual bugs, I started to see them everywhere. In fact, let me show you a couple of examples. This is Cineworld. This is the second largest cinema chain on the planet. So this is not a mom and pop type of shop, right? And they had a visual bug on the page that asked their users if they want to store their credit card information. Notice there, the two labels are not aligned with their respective radio buttons. And this seems like, funny, maybe low priority bug. If you had to open this bug, what severity would you open it at? But before you answer that question, let me ask you another one. Would you store your credit card information on this page? Probably not. I wouldn't. And let's ask ourselves, why wouldn't we store our credit card information here? Well, as Kim alluded to in this tweet, we've lost trust. If you were to see a page like this, there's no way you're going to give them your precious information to store, because you look at this and you think, if they didn't catch this, they probably didn't test it. But I have a theory. I think they did test it. In fact, I think that they automated the test for this. If they automated the test for this, again, it will be querying the DOM so it knows, oh yeah, the labels are present, the radio buttons are present, it can interact with it, it knows which one is which, and our test pass. And that's how this type of thing gets shipped to production. Here's another one. This is OpenTable. So OpenTable is used to make restaurant reservations. And I used to live in North Carolina a while back, and I went to visit a couple of years ago. And North Carolina is known for its barbecue. So I wanted to go to my favorite place, the Pit, and I wanted to catch up with some old friends. So I went to OpenTable to make a reservation for 7. So not a small reservation, right? And they gave me some times that were available, and I went ahead and clicked on that 7 p.m. slot. And when I did, a modal appeared. And I didn't know what to do at first because there's nothing centered here. But when I got to looking over here in this corner, I saw that, there are 2 select buttons there. But this posed more questions, because why are there 2 select buttons, right? Why are they not aligned? What is it that I'm even selecting here? So I did what any of you would do. I opened Chrome DevTools and I began to dig around in the DOM to figure out what on earth is going on. And when I did this, I realized that the labels were there on the page. They were just as far away from the buttons as possible. Now, because I was able to dig around in the DOM, just like our tests do, I was able to complete this reservation, right? I'm a greedy girl. But I couldn't help but think about, wow, how much business has this restaurant lost because of this visual bug? You know, most of their users are not engineers. They're not opening Chrome DevTools. They don't even know what that is. They're not digging around in the DOM to complete the reservation. And if they're a millennial like I am, they certainly aren't calling the restaurant. They just move on, right? But again, our automated tests wouldn't catch this because everything is there in the DOM and technically it's functional, and yet this company is losing so much money because of this. Now, these aren't just one-offs. This happens to your favorite tech companies as well, such as Amazon. Now here, not only is this a point of purchase, meaning someone's going to spend some money, right? They want to increase the quantity, therefore multiplying the amount of money that they're going to spend. And they're faced with this visual bug. Remember when I told you about the different viewport sizes? That's ripe for visual bugs, right? Facebook. This is their marketplace. You go here, you're trying to shop. Look at that text on the side. So this is not wide enough, right? Look at the text that's overlaying the images. All of these are visual things that would be missed. Our test can't catch this with the functional tools, right? It would say, yes, this text is present. Ship it. Instagram. This one is one of my favorites. This is sponsored ad, meaning some company paid Instagram to have premium placement on their application. And this is what they got in return. Again, let's think about our scripts. We'll ask, is this text present? Is this text present? Is this text present? It will say, yes, yes, yes. And this gets shipped, right? Again, think of the money loss, right? So if I'm a business and this happened to me, I'm getting 0 conversions on this advertisement, guess what? I don't spend money with Instagram anymore. Look at Twitter. And this is back in the day. You can see by how dated this looks. But look how their tweets were overlapping one another. What do you do if you open the app and it looks like this? You close it, right? There's nothing else you can really do here. Even our friends Google. Yes. So this one seems small, right? It's just some text kind of bleeding off of this button, but this is a point of purchase, right? They're not going to leave this like this. So that means some high salaried Google engineer has to stop innovating new features to go and chase stuff like this down. Not a good use of their time. The great news is we don't have to live like this, people. Visual testing can be automated. So what is visual testing exactly? Well, it's when, you know how we start writing our scripts, our automated tests, and, we're looking at the application, right? As a human, making sure everything looks right and we're scripting it in, right? At that point, we can take a screenshot of our application in its beautiful state. And this becomes a baseline image, right? And then every time we run that test as part of regression, it'll take another image and then compare the 2 images. And if there are any differences, it'll let us know. So now it's not just looking under the covers at the DOM, but it's looking on the screen as we would as human beings. Now, visual testing isn't something that's like entirely new. It's been around in the industry for a while now. But the techniques that we were using as an industry, not so great, right? They weren't really designed for testing. And that's by comparing these images pixel by pixel, which is not good. It's very flaky. Let me show you some examples. So in this top image, this is our application in its beautiful state. This is our baseline. That bottom image is a regression run. The regression test fails, right? This is part of CI/CD, so our deployment is blocked because of this. Who can see why this failed? If you said because this Google search button is bolded in the second picture but not the first, congrats, that's right. But it just so happens this is a hover effect, meaning if my mouse happens to be sitting over that button, that's the effect that it takes. Well, this is an automated test. This isn't run by a human being, which means that mouse just happened to be sitting right there. Something that we can't really control without writing a bunch of junky, complicated code to try to make sure our mouse is in the right position. That's not why we were hired, right? So this failed because of the pixel to pixel comparison. Here's another one. Who can see why this one failed? If you said because the cursor behind the word bad is there, but not in the second picture, that's exactly right. But cursors blink, right? So that means if we happen to have taken the picture while the cursor was solid, and then on a regression run and it wasn't, all of a sudden now we can't deploy. Again, not what we want. Pixel to pixel comparison was not designed for testing, okay? So fortunately, Amplitude has come up with a beautiful algorithm, right? Very innovative that uses machine learning to compare those images just as we would. It mimics the human brain and the human eye to be able to only detect the things that we matter. This is what we want for testing. Let me show you another little spot the difference game. Now, I'm not going to let you all play because you let the dead man get up and walk in the first game. So I'll play this one for you. And I actually ran this through a pixel to pixel comparison, and then I ran it through Amplitude's machine learning algorithm. When I ran it through pixel to pixel comparison, it flagged everything. Look at this. This is a mess, right? I don't want to deal with this as part of my test automation maintenance, right? Look at this. Every little white space shift is highlighted here. It doesn't really tell me what are the true meaningful differences. Versus when I ran it through Aptitude's machine learning algorithm, look at that. It was able to detect what I would detect as a human being. So this is what we want for testing. Okay, so we're going to actually add it. I'm going to show you how you can add this to an existing test automation framework. So you don't have to start over. You don't have to throw out what you already have. You add it to what's there. And the beautiful thing about the Amplitude's API is that it works with anything that you have. So if you're using Selenium and Java, if you're using Cypress and JavaScript, if you're using mobile platforms, Appium or XDUI test, whatever the flavor is, there's an SDK for you for visual testing. All right, so this is the application under test. It's a single page app, and this contains 8 of my favorite books on testing. And the way that this works is you can filter these books down. So you can just enter some text into that filter bar up top. There I entered the word test, and I can see the 5 books that have the word test in the title, okay? So here is our automated test before we add visual testing, right? So I'll walk you through this. We're going to query that word test, just like I showed you. And the books that I'm expecting to come back are these 5 books. So I put them in an array. And then I say, okay, go ahead and do the search on the page. And after the search is complete, I want to make sure that there are 5 books here. And it's however many are in that array, right? And then I also want to loop through that array to make sure each one of those titles is represented on that page. It's actually visible, right? Okay. Looks good, right? We got tests. You get kudos for having tests. But then the developer, they just learned some fancy CSS tricks, and they go into the code and they add this one line of CSS. And they check it in because you are so valuable and you have tests, so they feel very confident in making changes. They can just check them in and they know that your test has their back, right? So they check this in. Again, this is the test, right? This is the test that's going to run. And this is what the application actually looks like. With that one line of CSS, we literally flip this application on its head. That's okay because we have tests. You saw the test, right? So we run the test and oh no. Wow, I like green as much as the next person. This test should not be green, right? These books are literally flipped upside down and yet our test is passing. Why? Well, let's think about that test again. We said, here are the books. We want you to put in the word test. Make sure there are 5 books visible. Are there 5 books visible? Yeah, there are. Okay. And we said, make sure that each one of these titles is visible. Are those titles visible? They sure are. Again, querying the DOM has this unintentional blindness. So it misses that, this stuff is flipped upside down. Again, that's why we need visual testing. So let's add some visual testing here. The Amplitude's API is called eyes. And there are 3 simple commands. You first say, open your eyes. This is poetry, people. And then you say, okay, check the window. This is the magic. This is where it takes a screenshot of your application and it's going to send that up to the Amplitude's cloud. So you don't have to manage these images, it's all sent up. You don't have to worry with it. And then the final command is close your eyes. We're done here, right? So when we ran that same test again with the one line CSS that flips the application on its head, and we send this up to Amplitude, it does the visual comparison. It's looking at the screen. And so it can tell us, oh no, something is really wrong here. And it highlights all 5 of those books, letting us know this is not what we expect to happen, right? So this is great. Let's talk about the pros and cons of doing visual testing this way. Well, the pros is, if you notice, it's capturing the entire page. So I'm checking everything here, not just those 5 books, but anything else that might be unintentional that comes into the view. For example, if the books were overlapping, if a pink elephant flew across the page, any of the goofy things that we see as testers would be caught by this. A con is that it's capturing everything, right? And sometimes we might not want to capture everything. For example, the title of the page there, maybe I don't care about that. There could be other ongoing maintenance going on this page, so the page might not be stable, and therefore this test would be pretty fragile, right? Well, the good news is that we can scope our checks down. We don't have to check the full page. For example, if we just want to check one book. So in this test, notice here, and this is another con of visual testing across the board with aptitudes. You minimize the amount of code you have to write, right? So to check everything, I basically deleted a lot of code and I had a shorter amount to maintain. In this test, it's 2 lines. Do your interaction, which is on line 2, and then check the window. And instead of checking the full window, I'm going to pass in a couple of arguments here. So this is saying, okay, the target, I want you to target this down to a region, and here's my CSS selector for the region that I want you to check. And when we run this one, it's only going to capture that one book. So now we don't have a lot of noise here. So this is really powerful stuff, right? Pros and cons. So the pro, of course, is we've narrowed the scope. We like our test to be as narrow as possible so that we're only focusing on, whatever it is that's under test here. The con is we kind of reintroduced unintentional blindness, right? Because we're only focusing on a specific thing and not everything. So some bugs can creep up in here if we're not careful. For example, let's say filter is broken. So when I type in the word agile testing, nothing happens. Would the visual test that I just showed you that scoped this down, would that pass or would that fail? Take a moment. Take your guess. Write it in the chat. If you said that it would pass, you're correct. Why? Well, we asked it to look at that book, right? This book. We said, find that book. And we said, make sure it's beautiful. And that's exactly what it did. So this is interesting, right? Because we've talked about AI a lot today. And Aptitudes is utilizing AI for testing in a pretty innovative way. But we also get questions, and Joe can attest to this, where people are asking us if AI is going to take my testing job. The answer is no, right? This is using AI, but you are still in charge. You still need to control the AI and tell it what's your intention here, right? Because it's going to do exactly what you said it was going to do, exactly what you told it to do, right? And so you need to be sure that that's what you actually wanted to do. And that's not what we wanted to do. We don't want it to ignore everything, right? So what can we do to solve this? Well, you can couple your visual test with your functional test. You don't have to just do one assertion or the other. You can mix and match these to have a super powerful test. So here I re-added that functional assertion that says, make sure that it's only one book. So that takes care of the case where filter might not be working or there's more than one book that comes back when it shouldn't. And then on line 4, I do my visual scope down assertion where I say, okay, ignore everything else on the page. I just want to focus on this one area. And this is pretty powerful. Okay. Another question I often get is about dynamic content. People say, well, our app is dynamic. We're not using like static test data. So I can't use visual testing for that. Actually, you can. With Amplitude, you can, right? So there are 4 different match levels. This API is so powerful and flexible, y'all. The 4 different match levels, these are the algorithms that it uses to compare the images. So we didn't specify one at first, and so it used the default, which is strict, okay? The others are exact, which does pixel to pixel, but I already told you pixel to pixel sucks, so you're going to say no to pixel visual validation, right? Right. Okay. The third one is the layout mode. That's the one that does dynamic content. I'll tell you a little bit more about that in 1 second. And the final one is content. And this just verifies the content, but not the colors. So it kind of goes colorblind. And this is great when you have like, maybe your users can customize their profile colors or stuff like that. So you don't know what the colors are and you don't want it to check for that. You just care about the content itself. All right. So the layout mode, the dynamic part. So what this does is utilizes AI in a different way this time. It is going to look at the page and it's going to try to detect a pattern on that page for the structure of the page, right? So some customers that utilize this, I used to work at Twitter a couple of years ago, and we used this approach for those tweets, right? So I know that the tweets should have a specific kind of structure, like there should be, profile picture, there should be names, some text, maybe image or video, some type of media, you know what I'm saying? So it'll make sure that that all looks good and those tweets weren't overlapping anymore. News sites are another good example of customers that utilize the dynamic content mode. So they don't know what the news articles are going to be, but they have columns on their page. They have a certain structure. So AI is there to detect that structure and then verify that that structure is adhered to in your regression runs. So for example, let's say that our books can be in any order. It's not a predefined order, right? For example, in the left, that's the baseline image. And we have the Advanced Selenium book followed by the Cucumber book. But on the right, this is our regression run. And we have the Cucumber book followed by the Advanced Selenium book. And yet this test still passes. And why? Because we use the layout mode, right? So this is really flexible. And if we talk about pros and cons with this approach, again, pro, very flexible, very powerful. This is great when you're not using static test data. You don't know what's going to be there, but you just want to make sure everything looks good. All right. So this is a great use case for that. Cons is it's not testing the content itself. For example, when we switch the order of these books, let's say that I accidentally switched the order, the authors, and said Paul wrote Cucumber and Seb wrote Selenium. Dynamic content wouldn't catch that because it's not looking at it at that level, right? It's looking at the structure of the page, right? So I don't recommend using this for your end-all be-all test scenarios, this dynamic content. I use it for things like smoke tests, where I just want to make sure the app is up and everything looks good before I start doing deeper tests. And that can be more visual tests, but just using the strict algorithm. Or I'll use it when I'm testing the backend stuff, like maybe I'm bypassing the UI, right? We don't want a whole bunch of UI tests, and I want to do some backend testing, but I do want to just kind of double check to make sure that my front end looks okay. I can just do a dynamic content mode, make sure that everything looks good, and then verify the data on the back end. Okay. Not only can we use eyes just for the testing on one browser, but we can explode this actually. We can run this across multiple platforms, meaning multiple browsers, multiple types of devices, right? And this is crazy. This is like magic. Apple2's product is called the Ultra Fast Grid. And for any of you who have ever done cross-browser, cross-platform testing, you know that this is not fun to do, especially when you start like changing the sizes. Like maybe I want to test my app in desktop mode, and then I also want to test it in mobile view. Nightmare, because the elements start changing, right? So on the phone, you have hamburger menu, you have things more condensed, and there's different elements at play. So you start writing like all of this conditional code. You don't have to do that anymore. Ultra Fast Grid has come to the rescue. And the way that this works, you write your test once for one platform. Let's say I just want to write for Chrome desktop. That's it. But I do want to run across everything. Well, that's fine. Tell us, list them. List what the platforms are. Don't worry about changing your test at all. And what this will do is you write your test, you do your interaction steps with, your favorite framework, Selenium, Cypress, whatever. And what it's going to do is when you call that check window command, it's going to grab the state of your application. So your HTML, the DOM, your JavaScript, your CSS, it's going to grab all of that. And it is going to then blast this across all of the configurations that you specify in that state, meaning it doesn't have to run all of the prereq steps over again on all of these things. So this makes it lightning fast, and it's all running in parallel as well, which also increases the speed of this, right? So in doing that, here's where I specify the configuration. So in that eyes open command, notice here I have this browser here with these different objects. So I'm just saying I want Firefox, Chrome, IE in various heights and widths. Also support for Safari and Edge. Devices, I want iPhone 10. You can do iPhone 12 now as well. I want both landscape and portrait mode. I want Galaxy, name whatever you want. And notice our test there, line 17, test didn't change. Test is the same, right? And this can be used for all of the tests, so you don't have to rewrite it every time. And then what Apple2's will do is then, again, propagate that across all of those configurations that you specify, so you'll see how your app would look. I don't own those things. I don't have an iPhone 10. I don't have all those browsers installed, and I don't have to. I don't have to worry about a device form or anything like that. Apple2 just takes care of everything for me. And notice when I run that test, now I have entries there for all of those configurations. Notice that I have my desktop, I have my iPhone, my Galaxy, so I see everything. All right. So that is visual testing in a nutshell.